Let's take a look at an introduction to trigonometric equations. So first, let's review there are three types of equations. So an identity is true for all inputs, where all expressions are defined. So that just means that as long as the input is making each term defined inside the equation, then it's going to be true. So one example in trigonometry is our Pythagorean identity. So sine squared of theta plus cosine squared of theta equals 1. And we could have identity in like algebra or some other course. So think of something like x plus 2x equals 3x. So we could see that's true for, in this case, all real numbers. A conditional equation is only true for some inputs. So this is kind of more of like the typical equations that we would solve. So take a look at our example, sine of theta equals 1/2. I know this is true for some angles that make sine defined, but not all angles. So we could think like, oh, okay, like I can see that like pi over 6 would work, but say like pi over 2 would not work. Okay. Another example might be, say, x plus 3 equals 5, and then I get x equals 2, and I say, so x equals 2 is the only number that would make that equation true. Okay, and then an inconsistent or contradiction is just never true. So like sine of theta equals 5. That's never going to be true because there's no angle that would work. So we would just say this has no, these types of equations have no solution. So we know, when you look at an identity or you learn about them, we go, this is true for all inputs, like that one. But when we go to solve an equation, typically we have this case, right? It's possible that you could go to solve and you're like, oh, I'm probably in this, kind of in this area, and then go, wait a minute, this can't even have a solution. So that's possible. Then you go, oh, well, then I'm down here. Or you might have to solve something and go, oh, wait a minute, all real numbers work. So this is actually an identity. But typically we're kind of switching from learning about identities to now solving equations. Okay, let's look at some examples. Consider the equation 2 times sine of theta plus root 2 equals 0. So here we're just trying to remember, what does it mean when we solve an equation? What are we finding? Well, we're finding solutions. And what's a solution? Well, a solution is a value that when I replace the variable, it makes the equation true. So this is asking, is 5 pi over 4 a solution? So let's also remember the format for how we check. So to check or show the reader, kind of what's going on, we would have 2 times sine 5 pi over 4 plus root 2 equals 0. And I'm going to have a question mark over the top because I'm checking. So I'm not asserting this is true or false yet. I'm just saying, I'm just checking here. I'm just asking. 2 times, let's see, sine of 5 pi over 4. Well, 5 pi over 4 is down here, and then here to get to the sign is down, so negative. So this is going to be negative root 2 over 2 plus root 2 equals 0 question mark. And I'm keeping that question mark all the way to the end. Cross out my 2's, I get negative root 2 plus root 2 equals 0. Here's where it's tempting to remove the question mark because you're like, I know this is true. Wait to simplify both sides exactly. Here I get 0 equals 0, which is definitely true. And then I'm ready to write my statement. So is 5 pi over 4 a solution? I will answer that and say yes. 5 pi over 4 is a solution. Let's try this other one. Part B. Is pi over 4 a solution? So we're going to do the same check. 2 times sine 5, pi over 4 plus root 2 equals 0, question mark, over the equal sign. So this is 2 root 2 over 2 plus root 2 equals 0, question mark. Again, where am I at pi over 4? I'm on that main diagonal in the first quadrant. And here, sine, I have to move up to get there. So this is positive. This would give me root 2 plus root 2 equals 0. I'm keeping the question mark there, even though I can see this isn't going to work. 2 root 2 equals 0. And then I'm ready to state that this is false. So make sure that you write that's false. And then we're ready to answer. No, pi over 4 is not a solution.